Now, the solubility of solids with temperatures follows this sort of relationship. If I was to make a graph and I plot degrees Celsius on the bottom and the solubility on the side, then for most solids, the solubility increases with temperature. Maybe this is glucose. Maybe salt is down here, slightly increasing with temperature, sodium chloride. And maybe we have something like sodium nitrate. All of these, as we increase the temperature, the solubility goes up. So if we want to know what the solubility is at a particular temperature, we would find our temperature, go up, and come across, and read off our solubility off of our graph. So the trend with solids dissolving in water is that the solubility will go up with temperature. Now think about this. When you make tea on the stove, what do you do to get the sugar to dissolve? You don't add the sugar in while it's cold. You heat up the tea before you dump in the sugar. And the sugar goes in and you stir it up and it dissolves. So you can tell from your own experience that if you've ever made tea, that the solubility of the sugar as it's dissolved in the water goes up with temperature. It is a lot easier to get that sugar to dissolve in sweet tea when it's hot than when it's cold. So when you're thinking about solubility of solids with temperature, it's good to think about sweet tea. And what happens when you're making sweet tea and you're stirring sugar into the sweet tea? The solubility goes up with temperature. So solubility of solids goes up with temperature. Increases with temperature. Solubility of solids increases with temperature. That's the conclusion. The solubility of gases with temperature behaves very differently from the solubility of solids. It actually goes in the opposite direction of what solids did in liquid. Once again, we have degrees Celsius versus grams per 100 grams. But in the case of gases, it actually goes down with temperature. So say this is oxygen right there. So oxygen gas dissolved in water, the warmer the water gets, the less oxygen can be dissolved. This has particularly real-world implications for, say, fish. Fish that are in warm water have less oxygen available than fish that are in cold water. And so if the temperature suddenly changes in a small stream, in other words, on a hot day, all of a sudden the temperature of the stream goes from being cool to being very warm, the fish may actually run out of oxygen and die. The fish may actually suffocate because they go from having enough oxygen to not having enough oxygen in the water. So solubility of gases with temperatures decreases with increasing temperature. So the solubility of gases decreases with temperature, and this has very important consequences for fish on hot days. Now, the solubility of gases with pressure is helpful to think about in terms of, say, a soda can. If a soda can is sealed up and it has pressurized CO2 over the top. You know, when you pull the tab, it lets out a hiss because it's letting out all the extra pressure from the CO2 that's in there. And what's happening is the CO2 molecules are actually, by the pressure, are actually being pushed into the soda. And so now you have dissolved CO2 in your soda. That's what carbonation is. That's what that fizz is. And so you can imagine that if you increase the pressure inside the can, you'll actually push more CO2 in. You'll actually push more CO2 in. And this is how beverages are carbonated. They literally take the flat beverage, the soda syrup, mix it with some water, and then they inject CO2 gas into it under high pressure, and the CO2 gas ends up dissolving. So what does that mean? It means that if you increase the pressure, guess what happens to the solubility of the CO2 in the soda? Well, it has to go up. So increasing the pressure over here, you're pushing the CO2 in, you end up with more CO2 dissolved. So solubility of gases with pressure goes up with the pressure. So you increase the pressure, you can get more gas to dissolve in the water. So to help us remember that, we're going to have to remember what's going on with Pepsi or Coke. And that's how it's made. It's under pressure, and it's the pressure that's pushing the CO2 into the soda to make the carbonated bubbles after you open it up. So solubility of gases with pressure goes up. And we're going to say that is increases. The solubility of gas with pressure increases. The more pressure you put on the gas, the more gas is going to dissolve in the soda or in the solution.